Hey everyone, and time for another video, and today it's the turn of the 10-year-old dual-core Celeron E1400. Released in Q2 of 2008, the Celeron E1400 was a low-budget offering from Intel on the 775 socket. It cost $53 on its release, which is $61.93 today adjusting for inflation, but can be bought for as little as 50 British pence from CEX, which is around 66 US cents or 57 Euro cents. The E1400 features no turbo boosting or hyperthreading whatsoever, and has 105 million transistors on the 65nm fabrication process built using the Allendale architecture. It only has 512 KB of L2 cache, and also has an 800 MHz frontside bus, with a core multiplier of 10, giving it a core clock of 2 GHz with a TDP of 65 watts. It wasn't exactly much use for gaming in its day, but today we're going to be testing it anyway in a couple of benchmarks and a few games as well to see if it's any use at all in 2018. I'll be conducting all of our tests at both stock and overclocked speeds and at both 720p and 1080p for our games. The rest of the system we'll be using with the Celeron E1400 features 8GB of DDR2 RAM at 800 MHz, a MSI GTX 1080 ARM OC edition from my personal system to eliminate any bottlenecking, Windows 7 Ultimate 64-bit, and the Phanteks TC14PE to keep the Celeron cool. First up today, it's Cinebench R15, a multi-threaded benchmark popular with extreme overclockers designed to utilise your processor to render a photorealistic 3D scene. At its stock speed of 2 GHz, the E1400 managed a score of 67, putting it 6% slower than the Pentium D925 I tested previously, although the 925 was running significantly higher clock speeds than the Celeron does. Overclocking wise, I managed to get the E1400 up to 2.826 GHz before the memory started complaining, which itself is now at 942 MHz. At this speed, the Celeron managed to get a score of 92, a 37.31% increase over its stock score, putting it roughly 13% slower than the Pentium D925 with an overclock, although the 925 was running over 4.3 GHz at this point. Moving on, and it's time for SuperPi, a single-threaded benchmark which calculates pi to a set amount of decimal places selected by the user. We'll be running the 1 million preset today and conducting 10 runs and taking an average from that for both stock and overclocked speed respectively. At stock, the E1400 managed an average time of 32.769 seconds with a fastest time of 32.5, a couple of seconds down on what the Pentium E2180 managed at stock. With the 2.826 GHz overclock, the E1400 managed an average time of 23.885 seconds, a massive 8.884 second decrease from the stock time. Putting the benchmarks aside, it's time to move on to the games, and first up is The Witcher 3 Wild Hunt. Witcher 3 is based on the Witcher series of novels by Polish author Andrzej Sapkowski, and is a sequel to Witchers 1 and 2 and follows Geralt of Rivia on a quest to save his adoptive daughter Ciri from the Wild Hunt. FPS in the villages sat around the 15 to 20 frames per second mark, and dipped under 10 when turning the camera at points. Venturing into the wooded areas helped a bit, and the FPS increased to around 25 frames per second, but dropped into the low 10s in more detailed scenes with severe stutter and complete lockups lasting several seconds occurring as well. The game tended to stutter throughout, which often made combat and gameplay in general quite tough due to how bad it can get at times. The game is completely unplayable in this state, but I managed to get a 15-minute Fraps Benchmark anyway, which showed an average of 28 frames per second, with 1% and 0.1% lows of 8 and 2 frames per second respectively. Dropping down to 720p made things much worse. Not only was the FPS lower in the villages, but the stutter was worse too, and the lockups lasting several seconds persisted, happening more often than at 1080p. Performance in wooded areas was pretty much the same, but the stutter in general was much worse than 1080p throughout gameplay. I actually didn't even bother running a benchmark, as the game was unplayable anyway and showed no improvement over 1080p at all. Overclocking had no effect at all in terms of playability. FPS did increase in the villages and in the wooded areas too, but there was still some stutter throughout gameplay, and the lockups were also there too, and just as game breaking. The performance was so bad that I again decided not to bother benchmarking it due to how unplayable the game still was. I did however manage to benchmark 720p for an overclock, which showed frames per second in the low to mid 20s in villages, with some stutter and FPS in highly detailed areas dropping under 20. As mentioned, there was still some stutter, which the Fraps Benchmark shows, with an average of 26 frames per second, and 1% and 0.1% lows of 10 and 1 frames per second respectively. Moving on to our next test, and it's Grand Theft Auto 5, the game that centres around the lives of Michael, Trevor and Franklin and is set in the fictional US state of San Andreas, which is based on Southern California. We're testing the game at both 1080p and 720p for our stock and overclocked speed respectively, on the lowest settings we can with sharp shadows. At 1080p the game has massively long loading times, which is already in itself annoying, but the biggest and most game breaking of issues caused by the E1400 is complete and total lockups of the controls, causing some quite hilarious driving, making gameplay completely impossible and causing me to not even bother benchmarking it due to how much the lockups affect the game. The FPS in the city drops under the 20 mark and becomes fairly stuttery, and occasionally there were issues with texture popping as well, such as when the roads didn't even render at all. 720p improved the game somewhat, but did nothing to fix the issues 1080p has. FPS in the city was still under 20, but with less stutter than 1080p, however the stutter still pretty much made the game unplayable, due to how bad it can get. I did hope for a better experience out in the desert near Trevor's house, but I was pretty disappointed with what I saw, as the performance was actually worse than in the city. A Fraps Benchmark over 15 minutes showed an average of 18 frames per second, with 1% and 0.1% lows of 7 and 6 frames per second respectively. Overclocking helped FPS a lot, but again couldn't transform GTA 5 into something that would be playable. FPS in the city had improved to between the low to high 20s, but unfortunately still suffers from stuttering. At points, gameplay is so visually jarring that it can actually be hard to see what's even going on screen. The desert area is pretty much a stuttery mess, and the input locking still remained but was massively reduced compared to its stock. I managed to get a Fraps benchmark which showed an average of 24 frames per second, with 1% and 0.1% lows of 12 and 9 frames per second respectively. Performance didn't really improve much, if at all, with 720p, and during a Fraps benchmark, the game completely froze, never to return. Performance hadn't improved to a playable point anyway, so I didn't bother rerunning the Fraps benchmark. Now it's time to move on to Rise of the Tomb Raider, the sequel to 2013's Tomb Raider that places the player in the position of Lara Croft on our quest to find the divine source, a supposed source of immortality, before an organisation called Trinity gets their hands on it first. We'll be running the game at 1080p and 720p on the lowest settings we can. At 1080p, the game suffered from some pretty bad loading times and was a terrible experience on the E1400. The FPS dipped to almost 10 and gameplay was extremely stuttery throughout, especially in areas of the Soviet installation, which was pretty much a slideshow at points. Combat was quite difficult but not impossible, and occasionally the game completely locked up as well. A Fraps benchmark showed an average of 22 frames per second, with 1% and 0.1% lows of 6 and 2 frames per second respectively, showing just how bad the game is on the Celeron. 720p made no improvement at all, and in fact, made performance even worse at times. The long loading times were still present, and the FPS sometimes dipped into the single figures. Gameplay was extremely stuttery throughout, and at several points throughout the game ran in what looked like slow motion with severe audio and video stutter. The Fraps benchmark showed an average of 20 frames per second, with 1% and 0.1% lows of 5 and 3 frames per second respectively. Overclocking made no improvement whatsoever with 1080p. The long loading times persisted, as did the severe stutter, with the FPS dipping as low as 6 at points, making for a horribly jarring experience. Combat was also completely impossible, with rather severe lockups occurring throughout the game. Animations also appeared to be broken as well, causing you to be able to walk around characters that were frozen in mid-animation. I decided it wouldn't be worth running the Fraps benchmark due to how broken the game was. 720p showed a minor improvement, but major issues such as the slow motion gameplay were still present. In the Soviet installation, FPS tanked massively, and the game was again fairly stuttery throughout, and was in no way playable at all. A Fraps benchmark showed an average of 27 frames per second, with 1% and 0.1% lows of 8 and 4 frames per second respectively. Our final game for testing today is Fortnite Battle Royale, the free-to-play and massively popular title from Epic Games as a battle to the death with up to 99 other players, with the last player standing being declared the winner. There are also other game modes featuring teams as well. Like the previous 3 games, we'll run Fortnite at both 1080p and 720p on the lowest settings we can for our stock and overclocked speed respectively. At 1080p, the game is playable at points in my opinion, but unfortunately for the most part I wouldn't recommend the E1400 for Fortnite. In the pre-match holding area, FPS can dip as low as the single figures, and on the battle bus, when people start diving out, the FPS ranges around the high teens to low 20s, with some really bad stuttering occurring too. On the ground, performance kind of varies depending on your location on the map. but for the most part it sits under the 30 FPS mark that most would consider the minimum to be playable, and has micro stutter throughout, which doesn't always impact playability but does often make it tougher than it should be. A lot of time was spent in the loading screen during rounds as well, which unfortunately meant that I couldn't run a Fraps Benchmark, as the loading screen would have massively inflated the figures, making the benchmark look better than it was. At 720p, performance wasn't particularly great, but did manage to better 1080p for a change. FPS was pretty much the same in scenarios like when diving or when you're in the pre-match holding area. Once on the ground though, FPS managed to reach over 30 frames per second and maintain that for certain areas, but dropped near 10 at other points. The game also suffered from some pretty horrible texture popping at times, causing you to get stuck outside buildings, not able to get in because no door had rendered yet. A Fraps Benchmark showed an average of 31 frames per second, which was inflated by the loading screens, with 1% and 0.1% lows of 12 and 4 frames per second respectively. Overclocking had a relatively big impact on gameplay, with FPS when people start diving from the battle bus managing to stay in the 25 to 45 frames per second range. However, it did still stutter a fair bit. FPS in the pre-match holding area was around 19 to 50 frames per second, showing a fair amount of stutter too. Gameplay on the ground was still stuttery and sub 30 frames per second, and a Fraps Benchmark showed an average of 42 frames per second, which was again inflated by the loading screens, and 1% and 0.1% lows of 14 and 6 frames per second respectively. 720p is where the best performance is found on Fortnite with the E1400. The game did still suffer from stutter throughout, but managed to stay relatively smooth on the ground, and was actually quite playable with a Fraps Benchmark showing an average of 48 frames per second, with 1% and 0.1% lows of 15 and 5 frames per second respectively, which isn't that much greater than 1080p managed, but was definitely smoother and more enjoyable to play. Overall, the 2GHz Celeron E1400 performed exactly as expected, with games such as The Witcher 3, Rise of the Tomb Raider, and GTA 5 being near, if not completely impossible to play. Fortnite on the other hand performs pretty badly too, but does become playable at 720p, assuming you are able to overclock the Celeron to at least 2.8 GHz. I also tested general browsing performance at stock as well, by attempting to watch one of my own videos on YouTube at 1080p. Unfortunately, the E1400 couldn't cope with it, as it was consistently dropping frames throughout and wasn't stable at all. So as well as being a no-go for gaming in 2018, I can't recommend the Celeron E1400 as being suitable for use in a regular everyday PC for internet browsing either. If you liked this video, please consider giving it a like and a share, or leave a comment if you'd like, and maybe even subscribe to my channel too for more content like this. Hopefully you'll tune in for the next one.